control. So the most okay. So let us start with flow and error control. So the most important responsibility of the data link layer are flow control and error control. Collectively, these functions are known as data link layer. So data link layer have these two functionalities: flow control and error control. I think I had explained this to you in the previous lecture, but let me still explain it. For example, say this is the sender and this is the receiver. Okay, so this is the buffer of the sender. Let us draw larger buffer. Buffer means memory of this sender, and this is the memory of the receiver. So some part of the memory is used for receiving the data. Let us say there are two slots available, or the receiver buffer is of 2 frames. So maximum it can receive 2 frames in its memory. But sender have a larger memory, so he can send frame 1, frame 2, frame 3, frame 4, frame 5, and so on. Let us say sender have sent this frame to receiver as F1. Then sender have sent this frame and it will be stored in the receiver as F2. And then sender will send the next frame, F3. But what will happen at the receiver side? Receiver doesn't have a memory to occupy that frame. So it will discard this frame. Then sender will again send F4. It will again discard. That means what is happening? There is no control over the sending of the data. There is no control over the sending of the data. Sender is not aware about what is happening with his frames, and receiver is not aware about what he is receiving. So he has only 2 frames to store. So if his memory is full, so the frames will not get stored at the receiver side. Later, this receiver will consume one of the frames, so it will consume and deliver to the application so that this slot will be available. And whenever the sender will send this new frame, it will be stored into F1. But there will be a problem of some of the frames that will not be stored at the receiver side. So in order to maintain this, uh, there should be a proper flow control. That means sender needs to understand how much data he can send before receiving the acknowledgement. Before receiving the acknowledgement, how much data he can send to the receiver. Okay, so this kind of the flow control is required, as well as there are different links in between, like routers, channels. So this also have the capacity of receiving the frames. So that capacity is also needs to be considered for a flow control. Okay, and what is error control? Error control means, for example, say sender is trying to send this frame F1, but in between the links, there are the different links through which this frame is traveling. If this frame is discarded or lost in the network, that means it is not delivered to the destination. Before delivering it to the destination, some of the path is broken, or the router have discarded this packet. Then this sender needs to understand what happened with his frame, whatever he has sent, whether it is received or not. So this is the error, that sender is sending the frame, but it is not getting delivered to the destination. So this is called as the error at the sender side. So these errors are required to be controlled. So this is called as the error control. So there are two mechanisms, services provided by the data link layer: flow control and error control. And some protocols that are required to be studied for this. So flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for the acknowledgement. So there should be some restriction at the sender side, that he should know the limitation of the receiver or limitation of the network, that how much data he should send so that it will reach to the destination. So that is a flow control. And what is error control? Error control is in the data link layer is based on automatic request. That means whenever some of the frame that sender is sending is broken or lost in between, so there should be a automatic repeat request that sender should send this packet again or send this frame again. We should call it as a frame because we are learning the data link there. So he should send a frame again. Okay, so this automatic repeat request is provided by a data link here, and that is called as the error control, or it is a retransmission of a data. Okay, so we will understand some of the protocols. So protocols are categorized into two categories, one for noiseless channel, ideal, and one for noisy channel. So in noiseless channel, we will understand this stop and wait protocol. In noisy channel, we will learn this protocol with little variation, stop and wait, ARQ, go back, and ARQ, and selective repeat, ARQ. So these are the three protocols that we are going to study here. Okay, so noiseless channel means, let us understand. Uh, Let us first assume we have an idle channel in which no frames are lost, no frames are lost, duplicated or corrupted. Duplicated means the same frame is received multiple times at the receiver side. So it is called as the duplicated frame. Or corrupted. Corrupted means data inside the frame is damaged or say corrupted. Some of the bits are changed or flipped from 1 to 0 or 0 to 1. That is called as the corrupted. Or while sending the frame in the network only, it is lost before receiving to the receiver. That is called as the lost. So we are assuming a noiseless channel where these problems are not, and there will not be such a channel where these problems will not be there. So in some extent, a little extent or more extent, the problems will persist there, but we will first understand what will be the ideal procedure for sending a data in a noiseless channel where there is no lost in data, no duplicated frames, or no corrupted frames. So the protocol that is used in noiseless channel is a simple stop and wait protocol. So we'll understand stop and wait protocol here. So there are two rules at the sender side. Very simple protocol. Let us understand this rule. So rule one: send one data packet at a time. Send one data packet at a time. So sender will send one data packet. Sender will send one data packet at a time. Send next packet only after receiving the acknowledgement for a previous. So this is the receiver. Send next packet only after receiving the acknowledgement for the previous. That means sender will send the acknowledgement. Acknowledgements. So this is acknowledgement. This is a frame. Acknowledgement means receiver will tell the sender that the frame he had sent is received successfully. That is told by the receiver with some data. So sender will come to know that his frame is delivered successfully, and then sender is allowed to send only when this acknowledgement is received. Sender is allowed to send the next frame only when this acknowledgement is received. So sender will wait for this time. So that's why it is called as the stop and wait. So it will send one frame and stop, and then it will wait for the acknowledgement. The acknowledgement will receive, and then again it will send, then stop, and will wait for the acknowledgement. So again, acknowledgement will be received by, then it will send the next frame. So like this protocol rules. Now what is at the receiver side? There are two rules at the receiver side. Rule one: send the acknowledgement after receiving and consuming the data. After receiving and consuming the data. Now, what is meant by consuming? Consuming means sender and receiver have the buffers, as I told you. This is the buffer at the sender side, and this is the buffer at the receiver side. So, receiver will receive the frame in his buffer, and then he will deliver this frame to application or the upper layer. Application or upper layer. Once this frame is delivered to upper layer, that means this frame will be removed from here, and then space will be created for the new frame. Then only it will send the acknowledgement. When it will send the acknowledgement, then frame will be received here, and then it will be delivered to the application or the upper layer, and then only he will send the acknowledgement. After consuming a packet, acknowledgement need to be sent. That is a flow control. Okay, so let us understand this with diagrams. In the same diagram I have explained you. This is a data or a frame, then for which it will send the acknowledgement, then it will again send the data, acknowledgement, again send the data, acknowledgement. So unless it receives the acknowledgement, sender will not send the next frame. Okay, so very simple protocol, but there are certain problems with this simple wait stop and wait protocol. So what are the problems that we'll understand? First problem is lost data. So if data is lost, then receiver will wait for the data for infinite time. That receiver is not aware whether the sender has sent a data or not, because data is lost in the network only. So receiver have received nothing, so he will never acknowledge it. He will never send the acknowledgement. Why? Because he has not received the data, so he will not send the acknowledgement. And as sender is not getting the acknowledgement, he is not allowed to send the next frame. He is not allowed to send the next frame as he is not receiving the acknowledgement. So this will be a deadlock. This will be a deadlock. That means a sender is waiting for acknowledgement, and receiver is waiting for the data or the frame. So this is the first problem. If data is lost, then there is no recovery. Second, lost acknowledgement. Now, it is possible that data will be received at the receiver and receiver will send the acknowledgement, but it is possible that acknowledgement itself will lost in the network. Acknowledgement itself will lost in the network. So this will again create a deadlock. Why? Because sender is waiting for acknowledgement here, but receiver had sent it, but it is lost in the network. So that's why receiver will never receive this acknowledgement, and he will never send the next frame. So this is the second problem. Third problem is a delayed acknowledgement. Delayed acknowledgement, that means after timeout ends on sender side, a long delayed acknowledgement might be wrongly considered as acknowledgement of some other recent packet. So delayed acknowledgement means once data is sent, but this acknowledgement have taken a lot of time to receive at the receiver side. It has received at the receiver, it has a receiver have sent this acknowledgement, but it has took a longer time to receive at the sender side. So this will create a problem. That means it will be considered as an acknowledgement for some other packet that was sent previously. So that's why the delayed acknowledgement also makes a problem in simple stop and wait protocol. Okay, so to overcome these problems, next protocol that is developed for noisy channel, because there is no idle channel where there will not be loss of data, there will not be delay, there will not be error in data. So like these problems are always occur in the network, in every channel. So there is no such a channel where these problems will not be there. So we will have to provide some solutions to overcome these problems of stop and wait protocol. So this stop and wait protocol is added with automatic repeat request. So this protocol is known as stop and wait ARQ protocol. Protocol is known as stop and wait ARQ protocol. So let us understand this stop and wait ARQ protocol. So this is used in connection oriented communication along with a TCP. So TCP protocol that you will learn in a transport layer, where you will find what is meaning of connection-oriented communication, or you can watch one of the lecture on TCP protocol, three-way handshake of the TCP protocol, or acknowledgement video. Okay, the next is if it offers error and flow control. So in previous stop and wait there was no error control. But here this error and flow control is achieved. It is used in data link and transport layer. Stop and wait mainly implements sliding window protocol. Okay, so this sliding window protocol we will be learning in coming lectures. With a sliding window protocol concept with a window sizes as one. Window size means a buffer at the sender side and the receiver side. So this is sender buffer, and this is the receiver buffer. So this sliding stop and wait ARQ protocol assumes that there is only one slot available in the sender as well as receiver. That is one frame. So receiver can receive only one frame at a time. So this is the size of the window. That is one frame. So three problems of stop and wait protocols are resolved by this ARQ protocol. So how these problems are resolved? So these are resolved with adding one timer called as the timeout. So this is a timer. That means it will set a time. Whenever it will send a packet, it will set a time. For example, say 60 milliseconds. And whenever this timer will expire, and in this timer, if he doesn't receive the acknowledgement, let us say this 60 milliseconds are ending here, and if in this time he doesn't receive the acknowledgement, then he will resend this frame. Let us say this frame 0. This will be resent. So he will again send this frame 0. Why? Because he had set the timer and he expected that acknowledgement will receive in this time. But if acknowledgement is not received in this time, then he will again send the frame by assuming that the previous sent frame is lost in the network. Then next is a sequence number is added. So this is also important for identifying the lost acknowledgement. For example, say he has sent the acknowledgement, but it is lost in the network. So with the sequence number, the sender will come to know that which frame is to be sent next. And one more sequence number is added to the data, and sequence number is added to acknowledgement. So this will help for the delayed acknowledgement. This will help for the delayed acknowledgement. That means a sequence number will be added to acknowledgement. So consider acknowledgement is added with the sequence numbers. Sequence number means a number from 0 to say in TCP it is a different. Here we are considering a size as 1. So there will be 1 bit used for representing a single sequence number. So how many numbers you can represent with 1 bit? So this is a 1 bit. So either you can write here 0 or 1. So 2 numbers, 0 or 1. So let us name this as this is 0th acknowledgement. So sender will come to know that for which frame this is the acknowledgement. For which frame this is the acknowledgement. So there will be 2 acknowledgements here, acknowledgement 0 and acknowledgement 1. And there will be 2 frames here, frame 0 and frame 1. Okay, because one window size is available. That means there will be a 1 bit used for writing the sequence number. So sequence number will be either 0 or 1. Acknowledgement number will be either 0 or 1. Okay, so how it solves the timeout problem in stop and wait. So what will happen in timeout? Sender will send the data. Data is lost in the network. And this is the timeout period. This is the timeout period. Okay, so this timer will start here once it has sent the data. And this timer will go on decreasing. It is 60 here, then 59, then up to 0 here. And whenever it will reach to 0, it will assume that data is lost in the network. So it will again resend this data. It will again resend this data. So it is called as the timer. So it will solve this problem. Then next is sequence number or data. So it will solve the acknowledgement problem. So if acknowledgement is lost, that means it will not received in this timeout time. So if in this time it is not received, then it will again send the data, and then it will again send the same acknowledgement here. It will again send the same acknowledgement here. So here sender will come to know that his data is delivered to the destination. And third is delayed acknowledgement. So this is solved by introducing a sequence number for acknowledgement also. So let us consider that he has sent ACK 0. For example, say he has sent a frame 0 here, frame 0, for which it will send ACK 1. ACK 1. Okay, so ACK 1 means actually acknowledgement numbers are always the next of next sequence number of received frame. So if received frame is 0, the receiver will send the acknowledgement as 1. Meaning of this acknowledgement acknowledgement 1 is that he has received frame 0 and he is expecting frame 1. Meaning of that is he is expecting frame 1. So if this acknowledgement is taking a longer time to receive at the receiver, then here the receiver will come to know that because it has the number ACK1. Meaning of this is the receiver have received frame 0 and he is expecting the frame 1. So he will send the frame 1 here. So even though the acknowledgement is delayed, then also it is not misunderstood. So this is use of this ARQ protocol. So let us understand in detail the ARQ protocol. Sender A sends a data frame or a packet with sequence number 0. Then receiver B, after receiving data frame, sends an acknowledgement with sequence number 1. Sender is sending a frame with sequence number 0, but receiver is sending acknowledgement with sequence number 1. I have told you why it is sends acknowledgement 1. Meaning of this acknowledgement 1 is that he has received the frame 0 and next frame he is expecting is frame 1. Okay, so that's why he sends a 1. There is only one bit sequence number that implies that both the sender and receiver have the buffer for one frame packet only. We have said that the window at the receiver side is one frame only. Okay, so let us understand with timeline chart. So this is the first scenario where there will not be any problem. Sender will send frame 0, receiver will receive the acknowledgement 1. Meaning of that is he is expecting a frame 1. Acknowledgement 1 means that sender should send the frame 1. So sender will send the frame 1. Whenever the frame 1 will be received at the receiver side, then this receiver will tell to send the frame 0. That means it will say the acknowledgement as 0 because there are only two frames, frame 0 and frame 1. So it has reached to frame 1, so it should again start from the beginning, that is frame 0. So it is telling acknowledgement 0. Okay. So meaning of acknowledgement 0 is the receiver is expecting next frame as frame 0. Now this is the second scenario where this frame 0 is sent by the sender, but it is getting lost in the network. It is getting lost in the network. And then timeout happens. Then timeout happens because receiver have not received anything, so he will not acknowledge. So this timer will expire and the sender will again send the frame 0. Sender will again send the frame 0 here, for which the receiver will reply with acknowledgement 1. And then sender will send the frame 1 and it will send the acknowledgement 0, which will get lost in the network. So again the timeout will happen and the sender will resend this frame 1, for which the receiver will again send the acknowledgement 0. Here sender will come to know that frame 1 is received correctly. Frame 1 is received correctly. So this is how the protocol works. So for more reading, you should read this stop and wait protocol from this reference. I have given this reference, gigs for gigs, stop and wait ARQ. You will find easier explanation.